So let's talk about the case of the improper fraction. With the improper fraction, what you need to do is to divide the numerator by the denominator. So we are going to get a certain whole number plus another fraction. So in this case, you see that the highest power of the numerator is 2, of x in the numerator is 2, and the highest power in the denominator is 1. So 2 minus 1 is 1. So since it is 1, then when we divide this, we are only going to get a certain factor. So this is equal to certain factor times x, then plus a constant b, then plus the remaining fraction, which is c divided by x plus 3. So let's find the LCM. The LCM is x plus 3. So I will try it. You see that ax will multiply x plus 3, then plus b times x plus 3. But there's x plus 3 here, so to cancel this one out, then plus c. So this is equal to 7x squared minus 1 divided by x plus 3. So since the denominators are equal, then we can compute the numerator. So therefore ax times x plus 3, then plus b times x plus 3, then plus c is equal to 7x squared minus 1. So let's expand all. So this becomes ax squared, then plus 3ax, then plus bx plus 3b plus c is equal to 7x squared minus 1. So let's group like terms. So there's an x squared here. So we have ax squared, then plus, here's 3a plus b, then x, and plus 3b plus c equals 7x squared minus 1. So you can see that from here, you can conclude that a is equal to 7, because here's x squared and here's x squared. And then you can also say that 3a plus b is equal to 0. And this implies that b is equal to minus 3a. Then we are left with this term, which is 3b plus c is equal to minus 1. So now, we said that b is equal to minus 3a. So let me label this as equation 1, and then this one as equation 2. So b is equal to minus 3a, a is equal to 7, and therefore b is equal to minus 3 times 7. So b is equal to minus 21. Then we know that 3b plus c is equal to minus 1. So 3 times minus 21 plus c is equal to minus 1. So minus 63 and plus c is equal to minus 1. Therefore c is equal to 62. So the rational function, which is 7x squared minus 1 divided by x plus 3, is equal to a. We got a as 7, so ax. So this becomes 7x, then plus b. b is minus 21, so minus 21, then plus c. c is 62, so 62 divided by x plus 3. So let's express this rational function as a partial fraction. So you see that when we divide the numerator, this is an improper fraction anyway. We divide the numerator by the denominator. The highest power here is x exponent 4. The highest power here is x exponent 2. So 4 minus 2 is 2. So we have a term which is x squared. So this is equal to ax squared. So since we have an x squared term, then it means we must also have an x term, so plus bx, then plus the constant, which is c, then plus another constant divided by this denominator. However, before I write out that part, you can see that this is, let me solve that here. Here is x squared plus 3x plus 2. We can factorize this. Two numbers that when we multiply, we get 2. But when we add, we get 3x. That is 1 and 2. So x squared plus x, then plus 2x plus 2. So when we factorize x here, we will with x plus 1. And when we factorize 2 here, we will with x plus 1. So we have into bracket x plus 2 and times x plus 1. So what it means is that we are going to get plus, so here's plus c, then plus d divided by one of these factors, which is x plus 2, then plus e divided by. So now let me write this in a very nice way. So this can be written as, so this can be written as 2x exponent 4 plus 3x squared plus 1 divided by, now that becomes x plus 2 times x plus 1, then that is equal to ax squared plus bx plus c and plus d over this, which is x plus 2, and plus e over x plus 1. So let's find the LCM. So we have x plus 2 times x plus 1. So ax squared will multiply x plus 2 times x plus 1, which is the same as x squared plus 3x plus 2. And plus bx will also multiply the same thing, x squared plus 3x plus 2. Then plus c, I also multiply the same thing, x squared plus 3x plus 2. Then plus d will multiply x plus 1. Then plus e will multiply x plus 2. So let me extend this there. So this is equal to 2x exponent 4 plus 3x squared plus 1 divided by x plus 2 times x plus 1. So let's equate the numerators. So we have ax squared times x squared plus 3x plus 2. Then plus bx times x squared plus 3x plus 2. Then plus c times x squared plus 3x plus 2. And plus d times x plus 1. And plus e times x plus 2. And that is equal to 2x exponent 4 plus 3x squared plus 1. So let's expand all of this. So here becomes ax exponent 4, then plus 3ax exponent 3, and plus 2ax squared, and plus bx exponent 3 plus 3bx squared plus 2bx, and plus cx squared plus 3cx plus 2c, that is for this, and plus dx plus d, and plus ex plus 2e, that is equal to 2x exponent 4 plus 3x squared plus 1. So we can now group like terms. So here's a exponent 4. There's no other a exponent 4 in this equation. So therefore we can say from outright. Okay, so let's write it here. X exponent 4. Then plus here's x exponent 3, x exponent 3. There's none either. So we have plus 3a plus b x exponent 3. Then now we come to x exponent 2. So we have x exponent 2 here. We have another one here. We have another one here. So plus 2 bracket 2a plus 3b plus c x exponent 2. And we are left with x. So plus, there is x here. So plus 2b. And then there is another x here plus 3c. Then there's another x here plus d. and there's another one here plus e x, and plus the terms without x. So what other term do we have? We have 2c. So we have 2c, and there's a d here. So plus d and plus 2e. And that is equal to 2x exponent 4 plus 3x squared plus 1. So from here, we can then write our system of simultaneous equations. So outright, here's 2x exponent 4. A is equal to 2. Now, we can then say that 3a plus b is equal to, there's no x exponent 3, so that will be 0. And therefore, b is equal to minus 3a. So b is equal to minus 3 times 2. Therefore, b is equal to minus 6. Then now, we have 2a plus 3b plus c x squared. Here's 3x squared, so that's equal to 3. But we know that a is equal to 2 and b is equal to minus 6. So 2 times 2 plus 3 times minus 6 plus c is equal to 3. So 4 minus 18 plus c is equal to 3. So minus 14 plus c is equal to 3. And therefore c is equal to 17. Sorry. So we now know c. So now let's come to the terms with x. So those ones are 2b plus 3c plus d plus e. And there is no x term here, so that's equal to 0. So let's simplify this further. B is minus 6, so 2 times minus 6. And plus c is 17, so 3 times 17. And plus d plus e is equal to 0. So minus 12, then 3 times 17 is 51, plus 51. Then plus d plus e is equal to 0. So if you add this, you get 39. So d plus e is equal to minus 39. So let's write this as equation 1. Then we are left with the last part, which is 2c plus d plus 2e is equal to 1. So c in this case is 17. So 2 times 17, then plus d, then plus 2e is equal to 1. So 2 times 17 is 34. So d plus 2e is equal to minus 33. So let's look at these two equations. We have d plus e is equal to, so let me write that here. D plus e is equal to minus 39. Now, let us subtract. So let's say this is equation 3 and this is equation 4. If we subtract equation 4 from 3, this d will go to 0. So we have e equals minus 33 minus 39 will be minus 33 plus 39. And that's going to give us 6. Sorry. So e is equal to 6. So since e is equal to 6, and we can find d, because we said that d plus e is minus 39. So let me solve that here. D plus e is equal to minus 39. And therefore, e is equal to 6. So d plus 6 is equal to minus 39. And therefore, d is equal to minus 45. So let me list the values we got here. We got a to be equal to 2. Then b, we got it as minus 6. And then c is equal to 17. Then d is equal to minus 45. And then e is equal to 6. So we can then put it here and write the final answer. So this fraction is expressed as a is 2x squared. Then plus b is minus 6, so minus 6x. Then plus c, so plus 17. Then plus d is minus 45, so let me use minus 45 over x plus 2. Then e is 6 plus 6 divided by x plus 1. So this is the final answer.